Hey, welcome back everyone. We've made it through all of the promises and asynchronous JavaScript callback hell stuff, and we needed to cover all of that so that we can start making requests. We're going to see how we can use JavaScript to get information from an API, like load movie data or search for planets in Star Wars or get a random joke, which you could also apply to things like logging someone in via Facebook or sending some data off to your own server to save to a database. It's all the same process. We send a request from the client side. And we have to understand asynchronous JavaScript and promises for a lot of the requests that we'll be sending because these requests take time. We talked about that in the previous section. These things aren't immediate. It takes time. They might fail. It could take 10 seconds. It could take half a second. It doesn't matter how long exactly. It just matters that it's not instantaneous. So we have to worry about things like callbacks and promises. So there are multiple ways of making requests. We're going to start with the old school, quite ugly and confusing and hard to remember way, XMLHttpRequests, which is standard across all browsers, but a newer, much more modern and simpler syntax exists, which is called fetch. So we'll see both of those. Then we'll talk about a library that's really, really popular to help you make requests called Axios. It's a third-party script we can include. It just simplifies the process. So we're doing the same thing. It's just a cleaner syntax. But before we talk about any of those options, we need to talk about this idea of ajax, which is a term you may have heard. If you're brand new to JavaScript, you might have come across this term. Ajax, it stands for asynchronous JavaScript and XML, which is kind of a misnomer because these days, most of the time we don't work with XML. We work with JSON. Nobody says Ajaj, but that's kind of what it is these days. So if you don't know what XML or JSON are, we'll get there. But let's just talk about this general idea. Back in the day, before Ajax was really a big thing, before single-page apps were common, we had one standard flow for loading new data or getting information from a server, which included a page refresh. Here's an example. MDN is not a single-page app. If I search for something here, like React, I don't know if they have much on React actually, but if I hit enter, you'll see my page does change. I go to a new URL and the page actually reloads. One more time, let's look for div. Watch this little bar here. We go to a completely different page. So what's happening here is the browser is sending a request for a new web page and it's going off to one of MDN's servers. Depending on this URL, this is the URL that we requested by hitting enter. This URL is then received. The request is received by the server, MDN server, wherever it is, and it compiles a new web page for us, including the HTML and CSS and any relevant JavaScript. It sends the entire page back. Our browser refreshes, and this is what we see, a whole new page. Contrast that with what happens here. This is a website called Can I Use? Let's go back to home, and we'll search for something. How about gradient? I'm going to search for gradient. The page never reloads. I don't go anywhere else. Data is being loaded. There is communication with the server, but it's happening behind the scenes. It doesn't involve a whole page refresh. We're not getting a new web page. It's a different approach. We're just getting some data, or Can I Use is asking for data from a server. It comes back, and then new elements are added to the page. If I search for something else, let's go back to transform. You can see what happens. I'm not moving. The page is not changing. Well, the page is changing. The contents are changing, at least some of it, but it's a single page that we are staying on. And this is really what Ajax is all about. The idea of Ajax is using these requests that we can make via JavaScript asynchronously, that's the asynchronous JavaScript, to load some data from a server or to send data to a server, to save something to a database, whatever it is. We're communicating with a server behind the scenes. Not in between page loads like we had here, where, I search for something else. In between those loads, in between what a user sees and the page refreshing, that is when the communication is occurring with the server. Here, the communication is happening while I'm on this page. It's happening in the background. And the general process is a request is sent based off of, in this case, a keyboard event. So if I type something else, what's another, how about arrow functions? So I finish typing. There's some sort of debounce on here, so it's not sending a request every single time I hit a letter. it's waiting until I finish a word or something. It's sending a request based off of my keyboard input. In the background it's happening. We get some response from the server. The response usually these days is in the form of something called JSON. In the past it was XML, which is what was most commonly used and where the name Ajax comes from, but these days almost everyone uses JSON. So JSON is just a format for sending data. Imagine you have data representing all of this information we see here. The elements themselves are not being sent as HTML, or the CSS is not being sent. All that's being sent is basically the text and some information that maybe doesn't show up, what's supported, what's not supported, and it's being sent as text, but rather than just plain text, it's turned into this JSON notation. It's a way of representing data. It's a protocol for communicating between servers, or a protocol for formatting data and sending it to another server or to another browser somewhere. So we're going to talk about what it looks like in depth in the next video. But if we open up our dev tools here and you go to the network tab, I just want to show you that we can see the requests happening behind the scenes. Let's search for something else like spread, and you'll see some activity over here. This activity represents different requests that have been sent. If we go to XHR, which we haven't talked about yet, but that's what we'll see next, XHR here is going to show us the requests that have been sent. And we can see here is one sent to a can I use server. If we open this up, this was the URL it was sent to, search equals spread, and some information was sent back. This is the data that was sent back. If we take a look at it here, this is the data that came back from the server behind the scenes. So we end up with some information. Let's see, MDN CSS properties, box shadow spread radius. So that represents this result right here. Then we have another one, operator spread, spread in destructuring, which is what we see here. So this information was sent back from the server, but it's not all of the information. It looks like there was a second request sent. And if we look at this, it's a lot more, but this is really the core of the browser support chart that is created. So we get the titles back. I guess they split it up maybe so you can get them faster. I'm not positive, actually. I'm sure there's a good reason why there are two requests instead of one that just gets everything at once. But here we can see a representation of the CSS property, box shadow spread radius. That's the title that we have here. We have, let's see, support. And under support, we can see all the different browsers. Here's all the support for Chrome and Edge. There's a lot of information here. So we won't go into detail on what this actually looks like. But the point is, this is not HTML that's being sent. It's not JavaScript itself. It's not actually JavaScript. It looks like JavaScript, but it's actually called JSON. It's simply a way of sharing data between a server and another server, a server and a browser, that we can then use in JavaScript. It's really easy to take JSON and turn it into JavaScript and do something with it. So we send a request, or in this case, the website sends a request whenever I type something. We can clear all of the requests we see here, just like that. We search for something else, like, what's another one? A CSS HTML property. How is it so hard? How about text decoration? Okay, so there we go. Some requests were sent. We've got the first one. The second one, it looks like it sent two requests. I had text-d, and then it sent another follow-up for text-deck. I must have been very slow in my typing there. And we get information back. This information is then parsed via JavaScript. JavaScript takes that information and turns it into elements on the page. It manipulates the DOM. So it's all happening behind the scenes. Some event usually triggers it, typing or hitting a button. A request is sent. Life goes on in the browser. While this request is gone, or while we're waiting for a response, JavaScript doesn't just sit there doing nothing. We talked about that in the last section, how this all works with web APIs. So the browser is sending that request, information comes back, then JavaScript takes the reins and decides what to do. Display some content in this case. Add some classes, make some tables, some whatever these are, H3s or something. Adds them all in the right order, and we end up with this page. Okay, so next we're going to talk about JSON in more detail, and then we'll start making our own requests. All right, so that was a brief intro to the concept of Ajax, asynchronous JavaScript, and XML. In this video, the last one before we actually make requests, we're going to talk about XML and this other thing I mentioned, JSON, JavaScript Object Notation. So these are two ways of basically formatting data so that you can send it from a server to another server or a server to a browser. It's a format for information. They both solve essentially the same problem. We have some data that we want to send. We need to figure out a common standard way of sending that information. So if we had some data about a user, for example, where we have name would be something like Todd, and then we have, email is something else, Todd@gmail, and age could be a number like 89. This is information, and I'm already formatting it in some way. This isn't actually JSON, this isn't XML, but there's tons of ways we could do this, right? We could just use arrows to represent keys and values. We could, what else could we do? We could do colons. Or we could go with XML, which is one format. I'll show you what it looks like. It stands for Extensible Markup Language. You can think of XML as a very, very broad, almost the parent of HTML. It looks like HTML, except the element names are very different. They're not actual elements. XML is a way of just grouping content and adding meaning to your data. So if we were to represent this as XML, we actually use tags like name. And then inside of that, we would put Todd. And then we could have another tag for email. And inside of that, we put todd@gmail.com. And we could even nest things. So inside of name, we could have first, and that would be Todd. Then we could have second. So it's very similar to HTML in the way that we structure things, the characters we use, but it means something entirely different. XML can represent any sort of information, like first name, last name. What am I going with second? Jeez, I meant last name. Email, whatever. HTML represents the structure of a web page. It uses similar formatting, but otherwise it has a totally different purpose. They both are encoding information so that it can be transferred from one machine to another across the internet, little tiny pieces of light or bits turning on and off. But XML is just a broad way of structuring data. So XML used to be a lot more popular. You'll still see it sometimes. It's actually kind of frustrating when you encounter an API you want to use that responds with XML. It's just not very common, at least in my experience. But in JavaScript, we have a way of taking data like this and turning it into a JavaScript object. Like if this was a JavaScript object, it would be name, which has another object. First, Todd would be a string. Last would be Smith as a string. And then another property would be email, todd@gmail.com. This would be an actual JavaScript object we could use that we structure based off of this XML. And JavaScript has a way of doing that. We can parse text that is XML and turn it into actual JavaScript so we can use it. But there is another format we've already mentioned, which is called JSON. And JSON is extremely common these days. It stands for JavaScript Object Notation. So it is not JavaScript. It looks like JavaScript. It shares a lot of things in common with JavaScript, but it is not the exact same. JavaScript Object Notation is another format for sending data. It's another notation, but there are some key differences. First of all, every key in JSON must be a string with quotes. We use colons instead of an object. We also can use arrays. We can have values like numbers, Boolean, strings, but we cannot store more complicated things, like functions as an example. So the bad news is that it's not actually JavaScript. The good news is that it's very close, which makes it a great fit if we are using JavaScript because we can translate between JSON and JavaScript very, very easily. It's a single function call inside of JavaScript. So here's one of the APIs we'll play around with later. This API is called Swappy or Star Wars API. And we can play around with this on their webpage. Let's look at Starships/9. This is just their documentation. It's a little preview of what you get back. And if I actually open up the DevTools and I go to network again, let's go to planets/3. You'll see that a request is sent. Here's our response. If I paste this over here, it looks like a JavaScript object, but it's not actually JavaScript at this point. But remember, it's being sent as part of a response. It's not actually JavaScript. What we would do is then take it, once we get it back, and translate it into a real JavaScript object, which is really, really easy to do. So this is another format of representing information. To take this XML and turn it into JSON, it would look almost identical to what we have here, except we would have quotes around every key. And actually, that's pretty much it. If we had more complex data, like if we had a function from JavaScript we were trying to turn into JSON, that becomes problematic, but there are ways around it. So to sum all of this up, JSON is a format for sending data. So is XML. XML used to be very common, hence the term ajax with an X. Nowadays, most people use JSON. And even though it's called JavaScript Object Notation, it's named that because it's very similar to JavaScript, that doesn't mean you can only use it with JavaScript. So these APIs we see will respond with JSON, like the Star Wars API I just briefly showed you. It sends you JSON when you send a request to it. But you can write a Python application that communicates with that API, receives JSON, and turns it into valid Python. You could do, you could do a Ruby application and do the same thing. So the name JavaScript Object Notation means that it is similar to JavaScript, but it's not something you can only use with JavaScript. You can interact with it with any other programming language. You just have to parse it. You have to turn it into valid JavaScript. And there's actually a formatter here. There's a bunch of them. Here's one I'm looking at, which will tell you if your code is valid JSON. So if I try and write some JSON that is not actually valid, like person is the string of Thomas, and then let's just start with that. Let's process that. Invalid. It tells me immediately. Strings should be wrapped in double quotes. Okay, so I use single quotes here. That should be double. And this has no quotes, which is valid in JavaScript, not valid in JSON. If I try something like hello or greet, which should be a function, it doesn't even do anything. It's just a function. JavaScript-wise, this is totally fine. But if I process it, it tells me strings should be wrapped in double quotes, expecting comma, colon, or a curly brace to close the object, not an opening curly brace. And it encountered an opening curly brace. So it doesn't tell me you can't do functions because this parser doesn't really care. It's telling me you're not following the exact rules of JSON, which say after a colon, you have to encounter a comma, another colon, or a closing object brace, like this object brace here, which is closed down there. So all of this is to say, yes, it's similar to JavaScript. It is not JavaScript. Okay, next, we're going to get practice sending requests a couple different ways. We'll get JSON back, and we will turn it into JavaScript and do something with the information. That's coming up next. Okay, so now we've talked about Ajax, we've talked about JSON, we've gotten all that stuff out of the way. We can move on to making our first request using the OG method of sending an HTTP request through JavaScript. It's called XMLHttpRequest. So these are objects in the browser we can create that have different methods, and we can use them to fetch data from an API to send data somewhere. Basically, they generate an HTTP request. And it's confusing. It does say XML in the name. That's just a relic from when XML was the standard. We can use XMLHttpRequest, also known as XHRs, to fetch any sort of data from an API. It doesn't have to be just XML. So this is the original way of doing it. It's clunky. It doesn't support promises. So we end up with a lot of callbacks if we have nested requests, things where we want to make one request, get information back, and then make a second request, which we mimicked back when we talked about promises a couple videos ago. We made that fake HTTP request function that we used. So we send one request, we have some callbacks, then within those callbacks we could send another one, and we end up nesting things. So no promises are supported. Also, this has always driven me crazy. Why is it capitalized this way? XML is an abbreviation, it's all caps. HTTP is too, but it's not capitalized except for the H. It always trips me up whenever I have to type these myself. And the most important thing that I don't like about XHRs, and nobody really likes, is the syntax. It's hard to remember. I have to reference it all the time. I guarantee you in the making of this video, the very one I'm recording right now, I'm going to have to pause at some point and reference some other code because I can never remember it. Fortunately, we have an alternative these days, which we'll see very shortly, called fetch, which arose out of the fact that people hate making XHRs. It's just annoying. But let's see how we do it now that I've made it sound horrendous. Just remember, this used to be the only way, so it's not like nobody used this ever. This was the only way of making a request. What we do is we make a new object. That object is created by calling new XMLHttpRequest with parentheses. Then we provide two callbacks, one to run if the request loads, if it's successful, one to run if there's an error. So we have once again that branching path, success and failure. Then what we do is we call the request object, which I called myRequest.open. We tell it what type of request, we'll make a GET request, and what URL to send the request to. We'll come back to the headers in just a moment. Then we finally send the request. That request is then sent after this line is encountered. If it's successful, there's no problem. This code will run. If it's not successful, if there's an error, this code runs. You can read more about it on MDN. I really like their documentation on it. And what I'll do to help myself out, probably more than this actually helps you, I'm going to copy this over into my file where I'll paste it in as a reference. Okay, so let's make a request somewhere. We're going to use this simple Star Wars API to start. It's free. You don't have to sign up for anything or register. There's no authentication. Let's look at what do we get if we go to /planets. Send a request. This is just a little viewer. It doesn't like that. Is there a list of planets? How do we see all planets? Okay, well, let's go to documentation. What are the endpoints? Yeah, we can just go to /planets. It should work. Okay, here we go. So we'll try making a request to get all of the planets, which is swappy.co/API/planets. So I'm going to copy this URL over, and we'll try sending a request to it. So the first thing we'll do is make our request object. We'll call this first request equals new XMLHttpRequest, like that. Then we have a couple different ways of attaching the callbacks. We can do what I showed in the slides, where we use onLoad and onError, or we can use addEventListener. So either one works. In general, I've already mentioned this when we're working with a DOM and adding click events and other sort of event listeners. I like to use addEventListener. So I guess we'll go with that, even though I didn't put it in the slides. Like I said, I pretty much never use this. So we'll do addEventListener for load. This is the code that will run. Let's just do an arrow function. If things go well, I will just console.log it worked. And then we'll duplicate this entire thing here, but listen for the error event. So in the event that it doesn't work, something went wrong, we'll console.log error. Okay, so we're just attaching these two event listeners. We haven't even sent the request. We haven't told it what URL to go to. So that's the next part. First request dot open. And you would think open would actually send the request, but it doesn't. We have to explicitly send it afterwards. So I'll put my URL in here. This is the URL I want to send a request to. Then we'll call first request dot send. Remember, this takes time, which is why we have to add our callbacks. If I put something afterwards, just like with a set timeout, all the stuff we saw in the last section, JavaScript moves on. This request is handled by the browser, one of the web APIs, just like set timeout. So JavaScript doesn't just pause like it does if I put an alert. It pauses and just waits and waits and waits. That doesn't happen here because JavaScript is not sending the actual request. It's done through the browser. So we'll console.log request sent down here. And this is what we should see appear first. And then our request hopefully comes back successful. We'll see this. If it does not come back successful, we'll see this. Who knows what will happen? So here's my page where I have it loaded. Request sent, it worked. I guess we just have to trust that it worked right now. But if we put some URL in here that we know does not exist, well, I hope that doesn't exist. Try it again. There we go. Request was sent and we got an error. So our two branching paths. Did it load? Was everything okay? Or did it suck? Did it not work? Was there an error? Which we just deliberately caused to make sure it worked. So that is the first part. Making a request object in XHR. XMLHttpRequest. We make it, then we attach our callbacks. Then, well, actually you can attach the callbacks after you open, but before you send. What's most important is that you send after you've configured that object. So the object represents an HTTP request. It's just a JavaScript object. It has different methods. It has properties. We're assigning a load and an error callback. We tell it what type of request we want to get request, telling it where to send the request to, telling it to send it. Now, what about the data that's coming back from the API? The whole point of this is to send a request and get something back. Right now, we're not accessing it. We don't even know if we get the correct information back. We just get a console.log. The way that we access that data is by referencing this.response text. Well, what does this refer to? It refers to the request itself. So why don't we just look at that request? I think we called it first request, right? So after this finished, which it already finished, we can see that here. If we look at first request, it contains a response and it contains this response text. If we copy this response text, let's see if I copied it correctly. Okay, this right here is a whole bunch of JSON. Everything we see is JSON. It's not regular old JavaScript, but it's a string of a bunch of JavaScript looking stuff. You can see it ends with a quote. It begins with a double quote. So if I save right now and my auto formatter tries to run, it's not going to be happy with me. It's not considered JavaScript, but we have a way of referencing it. So I'll get rid of that massive monstrosity down there, and let's try referencing the response text on first request. So in my slides, what I did was this.response text, but that won't work here. Why not? Any guesses here? It has to do with the fact that I'm using an arrow function. So an arrow function, remember, does not have the same rules of the keyword this. So this will not refer to first request if I use an arrow function. So I have two options. I can just reference first request dot text response text. We could console.log that. Refresh the page. Hey, all of our information. If I instead tried to do this, we will get undefined. There is no response text because this is not set to the first request. If I instead rewrite this as a standard function expression, now I can use the keyword this. So in this case, it probably makes more sense to use a standard function expression because we want the value of this to refer to the first request object. So this gives me this massive thing of text. It is not JavaScript, it's JSON. So the next step is to turn it into actual JavaScript. So here we go. We have a special method called JSON.parse. And we pass into that a string of JSON, like that. And we can save that to a variable. Let's call this data. And then we can console.log data. Let's see what we get now. Hey, check it out. This is now being presented to me as a JavaScript object. It includes things like count, how many results we got back, what the next page is. So it looks like it didn't give us all the planets at once because there's a lot of them. Instead, it gave me the first 10. And then inside of results, we have all of the different planets that we got back, 10 of them. And they contain tons of information. And this is an actual JavaScript object. So I could do something like loop over the results and print out each planet name. So I would need to access data.results, loop over that. So why don't we start there? Data, so let's do for let planet of data.results. We now have this awesome JavaScript object. It wasn't JavaScript before, we converted it. And we want for each one of these to print out the name. So we'll do a console.log planet.name. Refresh. Awesome. We are now sending a request, getting information back as JSON, converting it to JavaScript, iterating over it or doing something with it, somehow manipulating it, and then printing data out. So with what we've seen so far, it wouldn't be a stretch to instead display the information on the page or do something visual for a user it would be the same sort of stuff we've seen before. Creating an element, appending an element, selecting elements, styling them with classes, all of that, hopefully by now, we're pretty comfortable with. But this is kind of a lot of code, and it has some drawbacks other than the clunky syntax, which we'll go into in the next video. All right, so we saw the loveliness of XHRs, XML HTTP requests. It didn't seem that bad. I mean, it's a little extra syntax, but if this was the only way we had to make requests, we can obviously make it work. Where it gets kind of annoying is once we start making these requests that are dependent on one another. So for example, here we're getting all the planets back, or at least the first 10 planets. And if we look just on the API, this is our little dashboard. If we look at the data we get back, it includes residents and films, which are actually just references to other API endpoints. So if I wanted to take the first planet and look at the first resident of that planet, I would send another request to this URL. So let's do that through our code. We need to wait for the first request to come back. Then we'll look inside results. We'll get the first results, the first planet. Look in residents. We'll get the first resident and send a request to that URL. Let's see if it works. So up here, we would have to write our code inside the callback to make a second request. So we're getting our data. Why don't we just start by singling out the URL we want to request? So that's results dot, we want the first result, so of 0. We can start by printing that. Refresh the page on my web page. Okay, so that's the first result. Then we want residents, or we could do films. That might be more interesting. Why don't we do films? So we'll do data.results of 0 dot films. That's an array. We want the first URL that we get from that films array, which is right here. swappy.co/API/films/6. This is a URL that we can send a request to get more information. And it looks like, what is this? Film/6 is Revenge of the Sith. Honestly, I know almost nothing about Star Wars, sadly. I love sci-fi and fantasy, but somehow I've never seen them. So let's now send a request to this URL. So we have the URL. We'll save it to a variable. We'll call this const film URL. Then we have to do all of this again. So we make a new object, const film request equals new XML HTTP request, not capitalized, even though I always attempt to do it the first time. Then film request dot add event listener on load. Put our callback in here. Let's just console.log. Let's do this just to start. Then we'll add our other event listener if it fails. So for the error, that's what the add event listener for error. Add our function in here. We do have an event object, by the way, that we can use. Why don't we console.log error, and then also show the event object, that error event object. And then we need to actually send the request, but first we have to open it like we did down here. So film request dot open. We want to get request, and the URL this time is this URL right here, film URL that we extracted from the response of the very first request. So film URL. Then finally, film request dot send. So if it works, we should see this printed out first. We'll say first request worked. And then let's add a second console.log here. Second request worked. Let's give it a look. First, hey, second one worked. Let's take a look at what we get back inside of response or response text. We've got title. Let's just print the movie title. So we need to parse again. So this references the entire film request object. We want this dot response text, which is exactly what we did in the first request. We want to parse that whole thing. So we use that magic method that comes for free with JavaScript, json.parse, that turns it into JavaScript. We'll save this in a variable called film data, and we can just console.log film data now. Try it again. Now we have an actual JavaScript object and it contains information. So we sent one request to get all the planets. And we're just arbitrarily selecting the first planet and the first film that it appears in. It also appears, I think this planet, whatever the first planet was, Alderaan or something, I don't know, I might have made that up. Whatever the first planet is, it appears in 2 films. We took the first one and we requested information about that, using the URL from that film's array from the first result. So we couldn't make the second request until the first one was successfully completed. So we have to nest it inside here. These nasty nested callbacks. This is just not a good look. And it's still only, 2 levels deep? It's not bad. We're not even doing much with our errors at all. We're not handling them. We're not trying to make a subsequent request. Often you will try and make another request. If the first one errors, you might try something different. And then that subsequent request needs to have its own 2 callbacks. Things get very messy very quickly, which is really the main reason that I don't like to use XHRs, why most people don't like them. It's just difficult. It gets messy and nested, which is why fetch was created, which is what we'll see just after this video. Fetch supports promises, which makes it way, way easier to make subsequent requests or to handle failures. We need one catch. So if you didn't watch the promises section, definitely go back and check it out. It will help you really understand what is so amazing about fetch and promises in general. So that's coming up next. Okay, so that was a quick taste of XMLHttpRequest. It's a mouthful, both to say and also to type. Especially once we get working with a bunch of callbacks and nesting things, it becomes very messy. So this is where fetch comes in. Fetch is the newer way of making requests via JavaScript. It is something that essentially was created because XHRs, XML HTTP requests, were just obnoxious or difficult to remember, clunky. Things got messy with callbacks. They don't support promises. So fetch is the solution. The only problem with fetch is that it's not supported in Internet Explorer. If we take a look on MDN, you can see under, I'm on the page called Fetch API. Down at the bottom, browser compatibility. What we care about is this part right here. These are all more advanced features, but this part here, fetch in general, no support in IE. The main thing, aside from the cleaner syntax and easier to remember terminology, the main advantage is that it supports promises, which we spent a ton of time on. I hope by now, if you made it through the promises section, you can understand why promises are useful, especially when we're making a bunch of requests. So let's see an example. This is what it looks like. We call a method called fetch. We pass in some URL. Then that returns a promise. And then, of course, the promise is either resolved or rejected. If it is resolved, the value it's resolved with is a response object. It contains information about the response. Otherwise, we can catch a rejected promise. If for some reason the fetch didn't work, if our internet was just not connected for some reason, that would be one example. This code would run. So why don't we go back to our app.js. This is what we had from the last few videos. Let's rewrite this using fetch. This is done with creating a new XML HTTP request. I'm going to copy the URL from the very first request we send right here so we can recreate this. And then I'll comment it out. Okay, so we're going to call fetch and pass in that URL. So if I just ran this code in my browser, I'll save it to a variable so we can check on the status of the promise. We'll call this, well, I don't want to go with promise. How about prom? If we look at prom, no, not promo. Well, it's now been resolved. If I just paste it in and run it immediately, it's pending. But eventually, it's either resolved or rejected. And really, all I wanted to show you here is that we're getting a promise back from that fetch method. So in order to run code when it is resolved, we need to use then. In order to run code if it's rejected, we need to use catch. So we can chain on our .then. .then, it will be resolved with a response object. We can call it response. And if you want to learn more about the details of the API, if you go to MDN, there's a lot of articles actually about it. We've got this overview, using fetch, fetch basic concepts, very useful stuff. But here's the key thing that you should know. The fetch method takes one mandatory argument, the path, the URL that we're trying to fetch, and it returns a promise that resolves to the response to the request. So the value that we would have that is passed in to our callback when this fetch promise hopefully resolves is a response object. And if we console.log that response object, you'll see it's a little different than what we've seen from XHRs. I'll try running this, refresh my page. This is what we get back. A response object, it contains a status code, 200, which means okay, that's good. It also has things like the URL that we requested, and then the data that we want is located in the body. But it's not as simple as reading a property from this body. If you notice what it says here, it's a readable stream. Without going into too much detail, if we take a look at the response page, the response reference on MDN, this is a response we get back. It's resolved with a response object. You can name that parameter whatever, but it will be a response object. If we read a little bit more about it, scroll down somewhere on here. Where's body? Here's body. It is a readable stream. Now, what is a readable stream? It is a stream of byte data. And this is one of the key differences from using XHRs. Aside from the actual syntactical differences, when you make a request, you get a response object back. The content of that response is included as a readable stream, and a stream is a way of accessing data that could be super large. It could be a massive amount of data, and you can access it and process it as you go. Now for us, that doesn't really matter. We're not accessing extremely large things. We're doing simple requests and just to get some data from an API. So it doesn't really matter, except that we have to be aware of how we read that stream. Fortunately, if we go back to the response object, we scroll down to methods. There's a nice method called .json. It takes a response stream and reads it to completion. So right now, our response has not actually been read to completion. It's a response object, but the stream has not been read. Fortunately, we have a very, very easy way of doing it, as I just showed you. Response.json. The only downside to this is that it takes time. It's asynchronous. That stream could be very, very large, and reading it fully could take a while, relatively, compared to something like json.parse. So because of that, this JSON method returns a promise. If we console.log response.json, this is what we get. It's another promise. So we have a promise returned from this, and then another promise from this. So if we actually want the data, we need to do another .then, and it will be resolved with the data that is read and parsed. So now we could console.log data. So it's an extra step. If we compare that to what we did up here, all we had to do was json.parse the response text. Here we call a JSON method, and then when it finishes, it's resolved, we can have access to the data. And there we go. Now we have our API data with the results, and we can do whatever we want with them. So why don't we do something simple like print out each planet? So we would have data inside of this .then callback after we've read the JSON. Data dot, and then results, I think is what it was. And we'll loop over that for let planet of data.results. We can double check this. Data is this whole thing. Results. We'll do what we did earlier. Console.log planet.name. Run it again. There we go. We're getting every planet's name, at least the first 10 planets that we're getting from this one API call, sending a request to this URL. So this is the first part of fetch, when things go right. We don't have any errors, or if we do, we don't know about them. So let's put a catch in here. If fetch returns a promise, it's resolved or rejected. Right now, we're not catching it, so why don't we catch and do something where we console.log something went wrong with fetch, and then we can console.log error as well. Let's see what happens. Right now, nothing should happen. We should still see the same result, but why don't I try fetching some URL that doesn't exist? If I visit this URL myself, just in the browser, this page is not the page you're looking for. This is a 404 error page. And when we got a 404 with XHRs, with this approach, our failure callback ran. this onError callback was executed. However, fetch is different. If we try and send a request to this URL, which I am telling you now will give us a 404, let's take a look. We did get a 404, but our catch never ran. Uncaught in promise, unexpected token. So what's happening here is that we're actually getting the HTML 404 page back, and we're trying to parse that as JSON, but it's not JSON. So why don't we start by just console.logging the response in here? Because it seems like if the status code is 404, then the .then should not run. That seems like an error where our catch should run, but that's not how fetch is set up. If we look at the response, status is 404, but it still worked. It still ran our .catch. The promise was resolved. So what's going on? Well, this is just how fetch is set up. If you take a look at this paragraph here on the using fetch overview on MDN, the promise returned from fetch will not reject on error status or HTTP error status, even if the response is a 404, which is not found, or 500. Instead, it resolves normally, and it will only reject on network failure, or if anything prevented the request from completing. So this .catch is not going to run. The promise will not be rejected just because the server responded with not a 200, not an OK status code, because we still got a response. So that's all that this cares about. This code runs whenever you get a response, whether it's the one you wanted or not. Unlike our XHR, where the failure callback would run, the error callback did run on a 400 error, or 404, excuse me. So fetch will only return a rejected promise in the event that your internet's not working, the request can't be made at all, and we just don't get a response. And I can show you that if I turn my internet off, so that's what I'm going to do. Okay, it's off. Let's refresh. Now it's actually running that catch callback. Something went wrong with fetch. Type error failed to fetch. So it didn't get a response, period. So the then callback was ignored, the promise was rejected, and this runs. So inside of this callback here, if we want to ensure that we actually got a status code 200 and OK before we try and read JSON, before we do anything with it, what we can do is check if response dot OK. That is a property on the response. Well, we don't see it here, but we did see it earlier. If that's the case, then we can run this code. Or another way of doing it would be if response is not OK, then we could console.log something, error not status 200. And then we can wrap this in an else, because we only want to attempt parsing. If the request came back status 200, if instead we got a 404, we'll just print this out. And we could also console.log response.status. So now, if we try it again, here we go, error not status 200, we got 404. And this code did not run. So this is one option, but we also have a way of using this catch. If I throw an error inside of a .then, it will trigger the callback in my .catch. So I could rewrite it like this, throw new error. If you've never seen how to throw an error, it looks like this. We'll say status code error, and then interpolate using $. Instead of a string template literal, I'll put response.status here. Okay, so let's test it out. This URL should give us a 404. If we try and visit it in our browser, it gives us a 404. Earlier, we saw that we got a 404 status code, which means not found. Then the promise will still be resolved. This code runs up until this point. This will be true because it is not OK. So then we throw a new error, which should trigger this callback, and the error will be this error we're passing through. When we throw an error, we have access to it here in our catch. So let's see. There we go. Something went wrong with fetch. Status code error 404. So this is the basics of fetch. I wish that you didn't have to worry about the status code, but that's where Axios comes in, which is another improvement upon fetch in my opinion. This is still better than what we saw here, although we were making 2 requests here. But as you can imagine with promises, which we automatically get from fetch, it's pretty easy to chain and make multiple requests in a row, which is what we'll talk about in the very next video. Next up, we'll see how we can chain requests one after another and avoid the messy callback situation that we had here using XMLHttpRequest. Really the main selling point of fetch, that we don't have to use callbacks and nest things and it just gets messy. Instead, we can use the promises and chain a bunch of .thens as long as we return promises from .then. So if we go with the exact same idea, what we had here, if we look at each planet, why don't we console.log the entire planet instead of just the name or in addition to the name, and also make sure we're actually requesting a valid URL now. Here we go. Each planet, as we saw, has films and also residents. We could request residents instead. Let's do films, and we'll just look at the first film that the planet occurs in. So we have Alderaan, 2 films. We'll take the first one just to match what we did earlier and send a request to this URL. So with promises, we always have a lot of flexibility. Do we want to do everything on one level, like one line of .thens? Right now, we have a .then that is currently nested inside of this callback, but we could avoid that if we wanted to. If we just return the promise, we can actually take this .then and move it outside, put it here, as long as we return response.json, which is a promise. And it doesn't like my semicolon. There we go. So now we return this promise and we add our .then, which will be run when this promise is resolved, and if it's rejected, we have our catch. So we just moved our code out and made it a little bit flatter, I guess, less nested, and it should still work. Let's check. It does. Okay, so now what we can do is make our request. We can still print the planet names out if we want, but I think I'll stop that for now. We're going to take the data.results.films0, which should give us a URL that we can now request. Let's console.log and cannot read property 0 of undefined. Let's see. .then data. Let's console.log data. I think I did it wrong. Results. That's why. I'm not accessing the correct result. We have to go to the first planet if we want the first planet. We could also pick a different planet, but we'll go with the first one to match what we did here. So this should work now. Let's make sure I'm getting the correct URL printed out. There it is. So we'll send another request here using fetch. So fetch of this URL. I'll save this to a variable. What should we call it? Let's go with const film URL. And fetch film URL. Now this is a promise. So I could put my .then right here and do all that stuff nested, or because it's a promise, I can return it. So return that fetch and then put another .then here. And we'll call this data also, or we could call it movie data. And then we can go through this exact same process. I could actually just copy this entire thing, and response is a better name rather than data because that's what we actually get. If fetch is resolved, it resolves with the response object. We have to check if it's okay. Then we parse it. We call the JSON method, which itself returns a promise. So we can add another then. Data. Why don't we console.log data? Okay, moment of truth here. Hey, take a look. We're getting all of that movie data. So we requested all the planets, which I guess I can add some console.logs in here. We'll do a console.log fetched all planets. Well, it's actually first 10. Then down here, we can console.log fetched first film based off of first planet. And then we'll just do data.title. Refresh. Fetched all planets, first 10. Then fetched first film based off of first planet, Revenge of the Sith. So here we have multiple requests that are happening one after another, but there's not really any nesting. It's all very flat. yes, we have some repeated logic where we have this, where we are checking for the response being okay. We're checking for, or we're parsing the JSON. We duplicate that at least twice. And if we made further requests, we'd want to do the same thing. But in the next video, I'll show you a way we can refactor it and clean it up even more. So here, really, if we're making a comparison, the main points I would make is, one, I can never remember this syntax. I can never remember the different pieces we need, the names, but that's just me, so that's not a great reason. The main reason that I think fetch is much better, and almost everyone I think would agree with me, is that we have promises that are returned from fetch. We can use those promises. We can keep things flat, linear, non-nested, even though this code here, where we make a request to get the film based off of this first request, this only runs if this happened. So if everything was okay here, we got the JSON, that finishes, then we make a second request. And we could have 10 different requests that are dependent on one another, but we don't have to nest them 10 callbacks deep like we would up here. So next we'll see a way of refactoring this and shortening it up. Then we'll move on to my personal favorite, Axios, the crowning jewel of making requests in my opinion. Next up, let's do some refactoring. So first, I'd like to change what we're actually requesting. Right now we're getting the first 10 planets and then taking the first one of those 10 and getting the first film URL and requesting that. If we look at the planets response that we get back, I'm on the docs, the API documentation for Star Wars API. It gives us a visual, little nice representation that's interactive. There is a property, there's a next that we can access. It's another URL to get more planets. So page set to 2. So why don't we get the first 10 planets, and then when that finishes, get the next 10, if there are 10, from page 2. We won't keep going. I don't know how many pages there are, but we'll just do the first 2 to start. So we'll keep this first request to get the first 10 planets. We'll run this code, but then here, we'll do fetched all planets, sure. Let's print out each planet again. So for let planet of data.results, we'll console.log planet.name. And then instead of a film URL, what we'll do is get the next URL, which is just at the top of the JSON we get back. It's called next. We don't have to look inside of results. It's simply data.next. So we'll save that to a variable called next URL. And then request that instead of film URL. Next URL. Then we have our same logic to check if the status code was not okay. We'll throw an error. Otherwise, we call the JSON method, which takes time. It's asynchronous. It returns a promise. We return that promise. Then we'll change what we're doing down here. Fetched next 10 planets. And then we'll just copy this logic right here to print out the name of each planet. Let's cross our fingers. Hope it works. Cool. So you can see the first 10 came back right there, and then a split second later, the next 10. So fetched all 10, there we go, and then fetched next 10, there we go. So yeah, we don't technically need to have this happen one after another. If we know the pattern for how we fetch the next batch of results, there is a pattern. We just pass in this query string page equals 2. If we change it to 3 or 4, we get the next page. So they're not really dependent, but let's say that we don't know what this URL is, and we want to send the first request and use this URL. So we're doing one after another. Also, it's just good practice with promises. But now what I'd like to show you is how we can clean this up. We have some duplicated logic. First, we are doing the same thing twice. Checking response.ok, calling .json. We do it here, right here, and right here. Then we're also doing this right here. It's pretty much the same, where we are fetching planets. So we could just write a separate function, a standalone function called maybe check status and parse. It's a bit long of a name, but that will work. And we can move this logic into the function, assuming that we also add response as a parameter. If we don't want to change this, we could go with res and update this to be res and res and res. What we'll do is pass this in to our .then. .then check status and parse. So it doesn't matter if we have a named function that this isn't technically a named function, but it's in a variable, slight difference. But it doesn't matter if we pass in a predefined function or an anonymous function, the promise, when it's resolved, will be resolved with a value this function is called, and that value will be passed in. So why not move it out so we can clean up our code, not have to have these long .thens with anonymous functions. We can replace this here as well. .then, check status, and parse. As long as we return a promise, which we are. We were already doing that. So I just moved it out. Let's see if it still works. Refresh. We got the first 10. We got the second 10. Cool. So this is a pretty good improvement, but wouldn't it be nice if we could do something like this? .then, like if we had this here, fetch planets, .then check status and parse, .then print planets, .then get 10 more planets, and then we could just duplicate this as many times as needed. So what if we had a method or a function to print planets? That's easy enough, right? What about getting 10 more planets? Well, it's relatively straightforward, but there is one caveat. In order for those .thens to work, they all need to return promises. And something like printing a planet or 10 planets probably won't return promises, but let me just show you what we could do. So I'm going to start by defining a function called print planets, and we'll just have it expect some data, the same data that we are expecting here. I'm going to move this logic out. I'll replace the console.log with loaded 10 more planets or something like that. And then for each planet of data.results, we still console.log the planet name. So I should be able to do a .then print planets. But then we'll run into an issue here. But we should see the first 10 planets print out. Let's verify. There we go. Then we get here, cannot read property next of undefined. That error is coming from this. Next URL, that's where we're trying to get the next URL, equals data.next. Well, there is no data that was passed in. We never called this ourselves. Remember how then works. It's run when, or the callback is run, this callback is run when a promise is resolved. But there's no promise being returned from print planets. The only way we can chain all of these together is if we return a promise. So check status and parse, that returns a promise. This is a promise here, or this method returns a promise itself. We return that promise. Print planets does not return a promise. However, we can fix that. It's nice and easy. We have a couple ways of doing it. First, the most obnoxious way would be new promise and go through the whole thing we've seen before. So we have resolve and reject, and we just want this promise to be resolved. We've printed them. We're not doing any checking of logic or error handling. We just want to automatically resolve. So we could do this const, I don't know, p equals new promise, resolve, comma, reject, and then we can just call resolve and return p. So we have an automatically resolved promise that we're returning. And what does it not like? Am I missing a paren? Forgot my arrow from doing an arrow function. Now let's see what happens. I'm returning a promise. So we got our first 10. And then the last thing I need to do is make sure I resolve with the data that this .then callback is expecting, right? We need to pass that data along. So I would just do resolve data. That's what we have here. It's being passed into print planets. We use some of that data. We print it out. Now I'm creating a new promise. I'm resolving it with that same data, and I'm returning that promise. This is kind of clunky, but it does work. But there's an easier way. There's a method called promise.resolve, and this will create a brand new promise for you that is resolved. So we don't have to go through any of that stuff. We can just return promise.resolve with data. So then this returns a promise, which means I can chain on a .then afterwards. And I'm resolving it with some data, the same data we had passed in. So I'm just passing it through again. I'm not changing data. It's being passed from check status and parse to this .then callback. And then we're using it, passing it along as we resolve this promise, which only exists to keep the chain of .thens moving. Then we have this .then, which we could turn into its own function as well. So why don't we refactor this? We're doing the same thing. We'll just do .then print planets. Does it work still? Do we get both sets printed out? Yep, looks good. So now what we could do is make another function called fetch more planets. Or how about fetch next planets? And it will expect a URL to be passed in. And if we're expecting a URL rather than the entire data, we could just do this, data.next. And data.next is the URL that we want. If we go back, that's the URL. So I'll just resolve with that value. If all we want is that next URL inside of the next.then callback, that's what I'll do. And this will simply return fetch of URL. So kind of simple, not doing anything crazy. I'm just putting a name on this function instead of using an anonymous function here. So I should be able to just change this to fetch next planets, and let's see if it works. We're returning a promise. We get our first 10, hey, and our second 10. Looks good. Already very short, neat, and easy to read, adorable code. And we could duplicate this as many times as we wanted, right? If I want to get 3 pages, I would print the planets and then fetch more planets, check their status, and print those. So now I should get 30 results. Awesome. First 10, next 10, final 10. And we could even use fetch next planets here instead of calling fetch if we wanted to. It's not really going to make a difference for us, but we could do this. Have URL default to this URL. That should be the very first place you look for planets if you don't pass anything in. And now I can just call fetch next planets with no argument. This returns a promise. It's returning fetch of this URL if I don't pass an argument in. But then all of these other ones right here, fetch next planets, fetch next planets, they will be passed the specific URL for page 2 or 3 or 4. And we should be good to go. Let's make sure. 10, 20, 30. Okay, so nice little refactor. Look at how adorable this is. Super clean and easy, and if I wanted to fetch 100 pages of planets, I don't think there are that many, and the API would probably get pissed at me. But if I wanted to, my code would not be any harder to understand. It would be longer, but it would still remain completely flat. Compared to doing it like this, it would be a nightmare to try and keep track of. So that is why fetch is so much better than XHRs, XMLHttpRequest. Also, this is just a mouthful to repeat. Fetch, much easier to say out loud. Next up, we have a third option for making requests via JavaScript. This is not a built-in option. It's not native JavaScript like fetch or XHRs. It is an external library called Axios. It's one of a whole bunch of different HTTP libraries that you could use. Axios is just the most popular, and I prefer it over some of the other alternatives, but it is by no means the one and only option. It's just the one that I like, and it's one that you'll be using throughout the rest of the course in a lot of the projects where we need to make requests. So you can find it by going to github/Axios. If you Google for Axios, there is this news website, Axios, which is actually pretty decent, but that's not what we're looking for. We're looking for the Axios GitHub, so you could just do Axios HTTP. Here we go. This is the official GitHub repository. You can see it has a ton of stars. It's used by almost 2 million people. Very popular library. So all that it does is it simplifies the process of making requests. It uses fetch behind the scenes, so it doesn't give us anything we can't already do. It's not somehow magically adding features to the language of JavaScript. It just simplifies things through a bunch of methods and objects that it creates that we can interact with. It is promise-based, just like fetch, so that means that we don't have to deal with a bunch of nasty callbacks. You can get a nice overview of the features here, but one of the most important features that people really like is that you can use it both in the client on the browser side of things, which is what we're doing right now, but also on the server side using Node.js, the exact same library, which is not always the case. So we haven't talked about Node, but in some of the projects we will work with Node, and you'll see how you can include a tool like Axios on the server side using Node and use the exact same syntax. So one library, one way of fetching data, let's say axios.get is the name of the method, that will work in the browser and in Node.js. But that's beyond the scope of where we are right now. So the first thing we need to do if we want to use Axios is we need to include it in our HTML file as an external script. So you can download it and have the files on your machine, but the simplest way is to copy this CDN right here. So a script where the source is set to an external source. It's not one of our files on our machine. This is a URL. And if we visit it right now, this is what we would be loading. This is the source of Axios. It's been minified and compressed into this massive chunk of very ugly text, but this gives us everything we need to use Axios. So we'll include that script, and we definitely want to make sure we include it before our own files that are trying to use Axios. Otherwise, we'll get an error if we reference Axios in our app.js, and we have this line down below. JavaScript won't know about Axios yet. Okay, so that's the first bit. Next, how do we actually make a request? There are a couple different options. There's actually quite a few. We can perform a GET request like this, axios.get, and then we pass in a URL. So it's kind of the same thing with fetch, where we do fetch, google.com or something. Instead, we do axios.get google.com. Why don't we just make sure the library is showing up? So I'll refresh my page here. Axios intro, we'll look at Axios. Okay, it exists. If we call axios.get and we pass in some URL, let's use the Star Wars API again. This URL right there, the same one we've been using, swappy.co/API/planets. I get a promise back. Why don't I save it to a variable? We'll call this const res, and we look at res. It's now been resolved. So just like fetch, we get a promise back when we make a request using Axios. Let's take a look at the value that it's been resolved with. Inside, we have a data property, and it's already been parsed for us. We don't have to parse it ourselves. That's one of the main advantages of using a tool like Axios, is that unlike fetch, we don't have to do the JSON parsing on our own. If we go back to our fetch example from earlier, I'll just uncomment the whole thing. Every time we make a request using fetch, I've moved these into separate functions if you didn't watch that video. So I've moved fetch next planets into its own function. It returns fetch, which is going to return a promise. Then we check the status code and we parse. So we have to check the status code to make sure that the response is okay, because fetch will resolve the promise as long as we get any response. It doesn't matter if it's a 404, an error not found, or if it's a 200, okay status code. So if we want to weed out those bad status codes, we have to manually do it. Then we have to parse on our own response.json. If we instead use Axios, those are not really a problem anymore. If we do axios.get this URL, we'll do a .then. It does return a promise as we've seen. Let's call this res. We console.log res. Refresh our page. Okay, res.data. It's already been parsed as we saw. We don't have to handle an additional promise, right? Because when we use fetch, response.json returns a promise, so we have to use a .then. So we end up with chaining multiple .thens, and it's not that ugly or anything. It's not the end of the world, but we do have to parse on our own. We get a string of JSON that needs to be turned into JavaScript. Axios already takes care of that for us. So it's doing the same thing behind the scenes. It's getting a string of JSON and it's parsing it, but we just don't write it. It does it for us, which is pretty nice. Now let's see what happens if we add on a .catch. Go with error as our parameter and console.log error. I'll do this on multiple lines. So right now, unless somehow my internet went down or the API went down, we still get our .then callback. But if I try and request a resource that doesn't exist, this should give me a 404 error. Let's see what happens here. Check it out. Request failed with a status code 404, error. My catch is what ran. We could make that clearer. Console.log in catch callback. The promise is being rejected. So this is another key difference between Axios and fetch. When we did fetch, when we used fetch, we had to manually check the response, the status code, because fetch does not reject a promise if status code is 400 or something else that is not okay, something other than 200, which is what we want. Axios and its developers, or developer, not sure how many there are, Axios knows that typically if there's a 404 or some other status code that is not 200 okay, you're going to want the catch callback to run, which is what we're doing here anyway. I'm throwing an error, which then triggers this catch callback. So it just simplifies things in two ways, as we've seen already. One, you don't have to parse JSON. Two, you don't have to weed out the bad status codes. Responses with a non-200 status code will be rejected, or at least I don't think it's every single non-200 status code, but the bad ones like 404. So that is it for now. I'll show you a few more examples with Axios in the next video. Otherwise, it works exactly the same way. It returns a promise, we chain with .then. If I wanted to make a second request, we'll see that in the next video. We just return another axios.get, just like we did with fetch. So to summarize this so far, Axios is an external library. We have to include it. If we don't include it there, we'll run into issues. We'll get an error saying, I don't know what the heck you're talking about. Axios is not defined. Once we include Axios, we can reference axios.get, which is the method we've been using. There are other methods. If you want to send a post request, you can do an axios.post. If you want to send some other request, a put or patch, if you've never heard of those, don't worry about it. But you can send those requests using Axios. It's nothing revolutionary. It's nothing that we can't do without Axios. It's just a simple, clean syntax that removes some of the minor pain points of using fetch. All right, so next we'll get some more practice. Next up, let's see how we can use Axios to make multiple chained requests, just like we did with fetch, where we refactored our code, so it's nice and clean, but we're still having to repeat a couple of things over and over. We start by fetching the first 10 planets, which is right here. Where are you? Right there. Then we check the status code. If it's not 200, we trigger the catch callback. Otherwise, we continue on. We parse the JSON. That returns a promise. Then we print the planets afterwards. And we had to work with this promise.resolve right here to print the planets so that we could chain on a .then again, so we could fetch more planets and keep the whole chain of promises going. Each one of these functions here returns a promise. To rewrite this with Axios, it saves us a little bit of code. So I still have Axios included. Change the title here. Axios chained requests. We'll start by running an axios.get call, which returns a promise. We need to put our URL in there. Then our .then. We don't have to parse, so all we need to do after that is print out the planets. So we'll go with res, sure. And actually, if all we want is the data, I'm just going to do res.data. I can use destructuring right here to grab the data out. And we'll console.log data to make sure it's showing up. Refresh the page. Awesome. So now we can print each planet. For let planet, same thing we've seen before. Planet of data.results. Console.log planet.name or something like that. Hopefully that works. There we go. We're getting the first 10 planets. Then we have that data.next URL. If we look in our data, next right there, we make a request to that URL. So it would just be axios.get. And then in here, rather than passing in a string URL that we create, we'll just pass in data.next, which is a URL. And if we want to chain on a .then out here, rather than right here, I mean, I can do this. This is totally fine. I could just copy this entire thing. I could make a second request this way, and let's just make sure that works. And I'll print the data out both times, and I'll console.log each planet name. Does it work? All right, so our first 10 and our second 10. But as we've seen, we can chain .thens by returning a promise. So I don't have to nest the .then like I have here. I could move this out if I return axios.get data.next, which itself returns a promise. So I can put the dot then like this, which is a little cleaner and simpler. Refresh, same thing. So that's kind of it. If you want to make one request and then another request using Axios, we don't have to worry about parsing. We don't have to worry about checking the status code. Otherwise, it's pretty much the same as using fetch, returns a promise, we put our dot then, continue the dot then chain as long as we want to make these sequential requests. So this happens here, then this, then this. So the only way we make this request is if the first one was successful. And we don't have a dot catch right now, so we could add that in. Dot catch, error, and what should we do here? Console.log, error, sure, something like that. So if we want to refactor this in the same way that we created this nice chain of promises where we just call a function each time, or pass in a function name each time to dot then, instead of having to use these inline anonymous functions, we can do that. I think I would go with, what would we call it? Same thing. So fetch next planets and then print planets, and then fetch next print planets, and so on. So let's try that. We can start with const fetch next planets equals function. It will accept a URL and it will default to this URL, the first set of planets that we want to fetch, just like we did earlier right here. And then all we do is return axios.get URL. Okay. So at this point, I should be able to rewrite at least my very first axios.get as just fetch next planets. And I won't pass anything in. We'll use the default initial URL. Just make sure that part works. We should get the first ones. Okay. And it still continues to work because we're not ever calling fetch next planets again. And then we can replace this with fetch next planets as well if we wanted to, although we will update this shortly. We'll pass in data.next, the same URL that we had before. Refresh. It still works. We get the first 10, the second 10. Now let's make a print next planets function. Print planets equals, and as a parameter, the way that this would work ideally is that we could call fetch next planets dot then print planets. Now fetch next planets is just returning axios.get of that URL. It returns the entire promise, and that promise is resolved with the entire response as we've seen, and we're extracting the data. So why don't we do the same thing, destructured data here, and then we can move our console.log, we can move all of our code right there, and then print the name out of each planet in data.results, and then we return fetch next planets again. So now I should be able to rewrite this. Then print planets dot then fetch next planets dot then print planets. There is one thing we have to pay attention to in order for this to work the way we've written it, which is that we need to manually resolve our promise, return a resolved promise, just like we did here. Back when we did a similar refactor with fetch, we returned promise.resolve data.next, which then calls the dot then, that is the ensuing dot then. We'll do the same thing, promise.resolve, and then we'll just pass in data.next. Whatever this value is will be used and passed into the dot then callback. So if this is print planets, we'll print out all the planets, then we return a resolved promise with the value of data.next, which is a URL. Then that is passed into fetch next planets because it's a next.then callback. Fetch next planets is expecting a URL to be passed in, and it is, so we don't use the default. Now we would use that next URL. Make sure it works, and there we go. Our first 10 and our second 10. So we could continue to fetch and print as many as we wanted. We'll do one more round. So I'm printing, I should fetch, and then print one more time. You could also move this, each pair, into its own function called fetch and print, and then that would return a promise, and you could chain multiple fetch and prints together. But this is pretty clean, and if we compare it to what we had before, the only difference is that we had to check for a status code and parse. but with Axios, we don't. So it's just slightly cleaner, slightly quicker and easier to use. We don't have to worry about the fact that we get a stream back when we're working with fetch and we have to parse the JSON, and that itself takes time. It's asynchronous, it returns a promise. We just get the data back when it's ready, and it's pre-parsed for us. So that's a brief introduction to Axios. You will definitely get a lot more experience with it throughout the project part of this course. We use Axios in a couple projects to make requests, both on the client and server side.